Alright, what's up guys? In this video, we're going to play with some calculus here. We're going to be talking about critical points. So we're just asked to find the critical points of the following function. So we're given the function f of x equal to x squared times ln of x. So to find the critical points, we'll take the first derivative of the function, set it equal to 0. So that's the first thing we need to do. So we need to calculate the first derivative. So to do that, or to differentiate this function, we need to apply the product rule. And so remember, if I have two functions I'm multiplying together, then the product rule says that I'll take the derivative of the first, multiply by my second function, which would be g, and then I'll add that to my first function f multiplied by the derivative of the second function g. Okay, so you can break it up if you want to and do them in small incremental steps. You won't need to write all this stuff down. If you're obviously an experienced calc student, this is obviously very easy. But for the purposes of the video, I'm just writing everything down. So you can imagine that f is x squared and then g is ln of x. And we know that if we take the derivative with respect to x for both of those, we'll get 2x if we use the power rule and 1 over x for ln of x. So that means that we would essentially get 2x times ln of x plus x squared times 1 over x. Thus, we can say that f prime of x will be equal to 2x times ln of x plus x. Alright, so to find the critical points, we'll set this first derivative, or we'll set the first derivative of this function equal to 0. So this would be 2x times ln of x plus x is equal to 0. We'll factor out an x from the left-hand side over there. So if we do that, then we'll just get x times, well, looks like we'll have 2 ln of x plus 1 on the inside and set that equal to 0. And you can always check to see whether or not you factor something out correctly by distributing it back in. So we know we'll get x is equal to 0, and then x is equal to, or not x is equal to rather, but we'll get 2 ln of x plus 1 is equal to 0. So we'll subtract 1 from both sides. So we'll get 2 ln of x is going to be equal to negative 1. We can divide both sides by 2. So we'll get ln of x is equal to negative 1/2. We'll take the exponential of both sides. So we'll have e to the ln of x is equal to e to the negative 1/2. E to the ln of x is just x. So that'll be x is equal to e to the negative 1/2. Remember, I could just write that as I could just write that as x is equal to 1 over the square root of e, because the square root of e, that's just e to the positive 1/2. Now keep in mind, I can just modify this and write it as that, because just think of x is equal to 1 over the square root of e. Just think of that as x is equal to 1 over e raised to the positive 1/2. And if I wanted to move it up, it would just change to a negative, giving me e to the negative 1/2. So I'm just kind of making that clear. Now, we know that our function x squared times ln of x is not defined at x is equal to 0. So there's actually only one critical point here, and it's just going to be x is equal to 1 over the square root of e. So the final answer for this, and there's just one critical point for this function. And the one critical point that will be for this function is x is equal to 1 over the square root of e. That's the only critical point here, because, again, our function x squared times ln of x is not defined at x is equal to 0. So it's just one critical point for this function. That's your answer. So the way you find the critical points, take the first derivative, set it equal to 0. If you want to find the inflection points, you would set the second derivative. You would take the second derivative function, set it equal to 0. That's how you would find the inflection points. Now, we're not asked to find the inflection points here, but I'm just kind of mentioning that So that's your answer. That's your critical point. So I'll post another example of this in the coming days, but check me out on my math YouTube channel and follow me on Instagram for more calculus content. I cover calculus 1, 2, 3, differential equations, linear algebra, complex analysis, anything you need, I got you. All right, I'll see y'all next time.